Your AI-generated test passed. That sounds like a win, right? But a passing AI-generated test does not automatically mean it is good, stable, maintainable, or ready for a real automation framework. A weak prompt can produce a passing test. It can also produce fragile automation that guesses selectors, ignores your architecture, and breaks the moment your project scales. The problem is not the AI model. It's that we ask AI to solve an engineering task without giving it engineering context. In my last 2 videos, I showed the workflow. Today, I want to zoom in on the piece that makes or breaks it, the prompt itself. In this video, I'll show you the exact prompt structure that fixes this, so the tests AI generates actually fit into your framework. This is how many engineers start using AI for test automation. They open Cursor, type something like "generate a Maestro test for guest ordering," and wait for the result. And sometimes, the result actually works. Cursor may generate a Maestro flow. The test may run. It may even pass successfully. But that is exactly where we need to be careful. Passing does not always mean production ready. A weak prompt can work when the repository already has strong structure, reusable subflows, clear naming conventions, and similar examples for the AI to learn from. But in a real project, the same weak prompt can easily produce fragile automation. It may guess selectors, ignore reusable flows, duplicate logic, skip important validations, or generate a test that works locally but becomes painful to maintain later. The problem is not always the AI model. Very often, the problem is that we ask AI to solve an engineering task without giving it enough engineering context. Test automation is not just a sequence of taps and assertions. A good test needs to fit into the framework. It should reuse existing components, follow project conventions, use stable selectors, validate the right behavior, and be easy for another engineer to review. That does not happen reliably when the prompt is only 1 sentence. So, instead of asking AI to simply generate a test, we need to guide it like an engineering assistant. We need to tell it who it should act as, what project it is working in, what scenario we want to automate, what quality means in this framework, which constraints it must respect, and what output we expect. The structure looks like this: role, project context, task, user scenario, engineering requirements, constraints, expected output. When we add these pieces, we reduce the number of assumptions the AI has to make. Instead of guessing the architecture, it can follow the existing framework. Instead of inventing selectors, it can prefer stable identifiers. Instead of generating a random script, it can produce automation that is easier to review, run, improve, and maintain. And this exact prompt structure, role, project context, engineering requirements, constraints, is what we break down in Lesson 7.3 of Module 7, Prompt Engineering Techniques for AI-Driven Automation. Inside the Advanced Mobile Automation with Maestro course, Module 7 is not about blindly trusting AI to write tests for you. It is about building AI-assisted automation workflows where Cursor helps you move faster, but you still define the quality, architecture, and engineering standards. AI can absolutely accelerate test automation, but only when we stop treating it like a magic generator and start guiding it like part of the engineering process. The link to Module 7 is in the description. Check it out when you're ready. Subscribe for more content like this. New videos every week on modern automation, AI workflows, and what it actually takes to grow as a QA engineer today.